see somebody on their phone.
I feel like every recording you say that. You see someone on their phone.
All right. Let's do number 4. We're looking at limits. So if your neighbor's talking, tell them hush. So 4 was the one that we did, I believe, on 1.4a that had to do with clever form of 1. And before I do, let's write something on the top. If you get to a question where we have 0 over 0 after we plug in, what must you do?
Do more.
Do more. And typically do more means factoring. For number 4, we're looking at clever form of 1. So in this case, the part we do not like is our numerator. Do we all agree on that?
Yes.
And our numerator has a clever form of 1, which is going to be, first put this in parentheses, the conjugate. And conjugate is basically the messy form with the opposite sign. In this case, we have plus. Top and the bottom. And because they're identical on the top and the bottom, that is clever form of 1. Now, do not worry about simplifying our denominator. Let's see if I'm going to have enough room. I think I'm going to go all around if you guys don't mind, since number 4 is the only one I'm doing on the top portion. So here I go. So don't we basically have difference of 2 squared on the top?
Yes.
Okay, let's see if we kind of remember. If I were to do difference of 2 squared, and I should have first done 0 over 0. It was do more. And that was after plugging our 0 into it. I was jumping to conclusion, as I tell you guys not to. All right, my difference of 2 squared for my first set is simply going to be x plus 25. Minus, how about my second component? 25. And on the bottom one, leave it as it is. Because something in the end is going to cancel out as a whole on the top and the bottom, as long as you don't distribute on the bottom. So do I have a 0 pair on my numerator?
Yes.
Yes, I do. That's not crossing out very nicely. So when I do, I'm going to rewrite this whole piece just because some people are going to be like, why did you cross that out? So I want to wait on that piece. If those of you guys that could see the 5, not the 5, the x will be crossed out, go for it. So could I now cross it out?
Yes.
Yep, let's get rid of it. So we have understood 1 on top, but once everything gets crossed out, I can now plug in our 0. So let's plug in our 0 and see what happens. We have 1 over, if x is 0, it's pretty much nothing, and I have square root of 25 is 5 plus 5. So this limit is reaching what number? 1 over 10. So don't make it hard by multiplying out the denominator, but do go ahead and apply difference of 2 squares on the top, and something as a whole eventually cancels out. We don't need our Chromebook. Not yet. All right, the next one is number 7. Do we all agree on that? Okay, number 7. We're looking at, okay. Now this one is basically one-sided limit. Now, some of the answers could be infinity or negative infinity. On your assessment, it'll be one or the other, and that's it. Nothing else. Okay? So 7 may be something extra on top of what you may see on the test. Let's start by plugging this in and see if we get something that might be, and let's write our rule, that has to do with negative or positive infinity. It was some number, not crazy small decimal, some any number divided by a very small decimal is going to give us what? Negative infinity. And some number divided by very small positive is going to give us what? Positive infinity. And if that very small number doesn't apply, it's going to be some number. And that's going to be number 7. So let's go ahead and plug it in. I want to go ahead and plug in 2. If you want to plug in 2.000001, that number is so tiny at the end, it's really not going to matter. So for the sake of this problem, let's just plug in the 2. 2 times 2 minus 3. That is going to give me square root of 4 minus 3. If you were plugging in very small number, it's 4.00001, which becomes irrelevant because it's 4 minus 3 some number. Square root of 1, how many is square root of 1?
1.
And this does not apply this rule or that rule, so it is reaching some number. So then number 10 is actually going to apply our rule on the top. On number 10, go ahead and plug it in, and you'll realize it's going to say, oh, I'll just plug it in with you guys. 5 over, and I'm doing this just like number 7. 2 minus 2 squared is equal to 5 over 0. And I know this does not exist. That means there's a vertical asymptote. What that really in the end means, when there is a vertical asymptote, sometimes our graph goes up abruptly, or sometimes our graph does what? Goes down, or sometimes both going up or down. Let's see how we can go about this problem without drawing the image, because some of us might have forgotten how to make rational functions. So on this one, let's write out 5 over very, very small number that is directly left of 2 for me is 1.999 repeated. So then when I do, just looking at my denominator, this number is going to be very, very, very small. What kind of number? Negative. So I'm going to write negative small number. And even if I take that negative small number and square it, that number is going to give me what? Very small positive, because when you square a negative, and that is going to reach infinity. So only when you're dealing with small positive, small negative, then it's going to go to the infinity or negative infinity. So let's do number 11, since somebody wanted 11 after 10, right? That's okay. Maybe that somebody needed more help. That's okay. What's up?
So there does not exist vertical asymptote thing, doesn't matter? It's just
this only leads us to say something has happened on the left abruptly going up or down, and we need to figure that part out. And in this case for us, it is going up. Okay?
It's not just one value.
Only on that one side. On one side. It is a one-sided limit. So for number 11, let's go ahead and plug it in as if we don't know what's happening. So I have 4 all squared minus the 4 over 4 minus 4 all squared. That should already be a ding, ding, ding right here. Because 4 minus 4 is what? 0. So just in case you're thinking, what is on the top? 12 over 0. Does not exist means there must be a vertical asymptote. Meaning at the vertical asymptote, the graph will either go up abruptly going up or down on one side. So in this case, I know you guys don't want to graph this, right? I don't either. Okay, let's assume you don't remember rational functions. We're looking at the number to the right of it. So let's, let me change my color. Let's write out the limit as x approaches the 4 from the positive, and I'm going to plug in some number. And in this case, how about we plug in 4.0001? Is that appropriate? Yeah. So 4.0001 all squared minus the 4.0001. And that's going to give us some number in my denominator of 4.001 minus the 4 all squared. So look at my numerator. We know when I square the 4, it's going to be a really big number compared to the 4.00. So that is some number. And yes, if you want to write 12, go for it. But look at your denominator. It's going to be a very, very, very small, what kind of number? Small positive number. Squared. And again, even if I square a decimal, it's going to be a bigger decimal. And that's going to lead to infinity. And yes, you may graph if you can graph it on paper. All right, let's do number 12. That's actually got 2 different sides, which actually makes it easier. The limit is approaching 0 from what side? The left. The left means less than. Which one has less than? The first one. So all you need to do is plug in the 0 into that equation. And that becomes very easy. The limit is actually reaching -5. So we like it when there's an inequality or piecewise function, even though back in algebra 2 you didn't like it. Okay? For limits, we like them. All right. Last question on this page before we analyze the second page. Are we all ready? Is that a yes? Okay, hopefully the recording is happening, because if not, I'm talking to myself. Not really, you guys are listening. All right, Luke, let's read. Find.
Find the values x for which f of x is equal to x5 over x squared minus 25. Identify which are removable and which are not removable.
All right, so we have removable and non-removable. When I cross out something on the top and the bottom, did I get rid of it? Has it been removed? So that means we have a hole. Non-removable will be vertical asymptote. So if you see me use removable, and not use the whole, don't be surprised, and so on for the next phrase. Which one can we factor out right now? The denominator, right? So we have x plus 5 and what else? X minus 5. And does something cancel out? When something's gone, is that removable or non-removable? Removable. So let's write out removable discontinuity. Discontinuity at, and I know this number is x plus 5. So if I set that equal to 0 in self, we get x equals what? Negative 5. So then let's continue our equation. We get the following. So do I have one vertical asymptote or two vertical asymptotes? Just one. Because the other one has been removed. So we have non-removable. Removable. And I'm just going to write disc as in discontinuity. And this one will be our vertical asymptote. I forgot to write whole on this one, but it's already on the question. So what is it at? X equals what? X equals 5. So these are easy, almost freebie, since we all know how to factor, if that is on the test. Okay, let's spend about 30 seconds picking 2 questions on the back. What's up?
With number 1, would you just do like high over low?
On number 1, would you do high over low? No, because that one's not infinite limits. It's actually reaching a number. It's reaching -1. Plug it in. Yeah, that's only for infinite limits. And we'll get to infinite limits on the packet. But I get it. Okay, take out the flashcards that we made if you're thinking, are we going to use this? And yes, I want you to memorize these. Oh, if it's, you can look at mine on the screen if you need. All right, let's see if we have good questions. Do we need more time looking at the questions? Yeah? Okay, who's got a number? Tell me. 14. Do we agree on 14? Anyone second number 14? I don't want to do an easy one. I don't know.
It has a K in it.
Yeah.
Is my reference already on the website? Yep, this week and next week's stuff's already ready to go. Okay, give me one more. 17. Whoever gave me 17, that's a good one. That's the one kids will be like, what? What are you talking about? Okay, let me go ahead and do these 2, and if you're like, give me one more, I guess I will. All right, so we're looking at, tell me if it is continuous by the given piecewise function. So if it is continuous, is there a hole or is the hole closed? It should be closed. So we know, isn't 2 equivalent to 2? So when that 2 is plugged in and that y value is equivalent, then we know it is continuous. So in this case, we're plugging in the 2 into this x, second 2 into my second function. So I have plug it in 2 squared is 4, so 4k is equal to 10 minus 2k. Are we okay with where the 4 and the 2 is coming from? Plug in the 2 into the x's. Then we want to solve for k. So I get 6k is equal to 10. And my last thing is k is equal to 10 over 6. I'm going to leave it as a clean fraction, 5/3. So determine the value of k. When is k continuous in this graph? It is when it is equal to 5/3. Here is the picture graphically. Listen up. We have a parabola. If I had a parabola, and I also had a graph that looked, for this case, something like this with an open circle. Right now it's discontinuous, right? Only when the k value is 5/3 and filled in, this graph is now continuous. Okay, somebody had their hand up? Yes, sir.
Where'd you get the 6K from?
6K came from plus 2K on both sides. We were solving for one variable. You add 2K. No. It's okay. I got it. Watch this.
Instead of it being K, think of it as
So we got 4K is equal to 10 minus 2K. Add 2K on both sides. 2K plus 4K. Are we good? No, we're not. That's okay. It might have been a brain fart, right?
It's like solving for X.
You're good. Do you feel silly?
Still lost. Hold on.
I got it.
Okay. This will never happen again. No, okay, never mind. I'm trying. Okay, number 17. All right, on number 17. Oh, Ryan wants to read. Read. If. That's right.
If f of x equals 3 over x minus 3 times 6 minus x, then f of x decreases without bound as x approaches what value from the right? In other words, limit of f of x as x approaches c from the positive direction equals negative infinity. Find c.
So if the limit reaches the infinity, go ahead and write this on the side. This is a hint. That means there must be a vertical asymptote where on one side it is going down and down and down forever. So our main hint is if there's any kind of infinity that is reaching of the f of x, there must be a vertical asymptote. Where does a vertical asymptote happen? Top or the bottom? Bottom, all right. How many do we have right now? 2. So let's take a step by step. Why is this up? So if I take a step by step, let's say our vertical asymptote, I'm going to write out x is going to reach 3 maybe. And then the second one, when I solve for x, x could reach what? 6? Vertical asymptotes happen on the denominator. If I solve for x on the denominator, we get 3. And then we have x equals 6. Y'all are being recorded. Go ahead and keep arguing. Stop it. All right, be nice. So we now get, let's go ahead and do 2 scenarios. So if you want to go ahead and make a division right now, division, like a little dividing line, go for it. So what I'm going to do is, let's make the limit reach the 3. And look at what the question says, from the right side. So the limit as x approaches 3 from the right side of this function. And for this function, I think I'm just going to write out f of x. Let's go ahead and plug it in. 3, no matter what, is always what? Positive. And it's 3, right? So I'm going to leave that alone. Go to the very, very bottom. If I plug in 3.00001 on my first factor, it's going to give me a very, very small what? Positive. So I'm going to write s as in small. And then if I plug in the 3 into my next function, it's going to give me about 3 still, right? But here's the idea. No matter how small my number is, if I take that number and still multiply by another number, it's still very small. Okay? So this one is going to reach infinity. And the rule for this one was a number divided by a very small positive, if you're wanting a reminder. Let's do the same thing on the right side of, or the other vertical asymptote. The limit as x approaches 6 from the positive, because it only wanted the positive. And let's plug it in. 3 remains. When I plug in the positive of the other one, we get a negative number. Is it a negative number? Yeah. And if I plug in a number that is greater than 6, I think for this one, I'm going to write it out. It says 6 minus 6.0001.
How'd you get a negative?
Yeah, it's probably 6 minus 3 is positive 3.
Oh, that's sad. I was having a moment too. I'm trying to make them feel better. Yes. Excuses.
Right.
Don't allow my excuses. It's not cool. So this one is going to reach what number?
Negative.
This one is going to reach negative infinity. And the question says, at what value of? So what are we looking at?
From the right.
Mm-hmm. So we know this one is going to reach that number. So our number is, oh, why would I put that on there? If c is equal to 6.
Wait, what does it mean decreases without bound?
Bound basically means, without bound means there's a vertical asymptote. It's just defining what the vertical asymptote is.
Oh, and that
It's
means
being
negative-
redundant.
That means negative infinity.
So then, on the left, would it be when c equals 3 to infinity?
So if it equals 3, it's going to be positive infinity, but the question asked us, when is it negative infinity?
Oh,
When c is approaching 6. All right, let's go to our third page, everybody. Third page, technically, there's 4 questions, right?
What's in 20 through 23?
Give me one.
20. 20.
Does everybody agree with that 20?
Yes.
Yep.
yes.
So really, I'm doing 2, 4, 11 questions.
Yep.
Got it. All right, let's do 20, everybody. Okay, let's get our vertical asymptote kind of like denoted easier than it looks. So it looks like we have a vertical asymptote where? 5-ish, 5, kind of,
5.1.
5.001. Kind of like here. I don't know. It's about here. Can we also put an arrow maybe up here somewhere? Where's my other color? This right here. On my endpoint, I don't really care about. Okay, let's see if I can get a different color. In pink, it's going to work out. Okay, let's do the ones that's going to reach numbers first. Let's start with B. If it's saying the limit is reaching a number without a positive sign or negative sign as an exponent, that's on both sides. Is everyone with me? Okay? So for B right here, it is reaching 3, circle 3. Now, limit is approaching. So if you guys would want to write on the side here, limit means it's approaching along the line. So here's my 3 from my left and from my right. What y value am I reaching? 8.
And it's not 10 because it's not part of the...
That's a point. That's not even a limit. It's not just random point. Okay, let's do another limit that's actually going to a whole number. Look at -3. So here's -3. It is reaching -3 from the left and from the right. Is that a common y value? That is, does not what? Exist. And that one you can't even put like even infinity because it's reaching 2 different numbers. Okay, where's the other one that's going to left and right? The 5. Let's go to 5. So here's 5. And if 5 is saying that we're going from left and the right. 5 from the left and the right. Is it reaching a number? So we can say does not exist. And if you're going, well, it also looks like it's going to negative infinity. Yes, you are correct. But does not exist is a better answer. Now, if it's a multiple choice, will I put infinity and does not exist? I would never do that, okay? It'll be one or the other. Okay, let's go to the other one that's got a non-power. Let's go to J. On my J, we're reaching 10. So here's 10 right here. So 10 from the left along the line, 10 from the right. Are we reaching the common y value?
No.
So we know that's what this one is. Does not exist. And then we can do K, yeah? K, -1. Oh, from the left and from the right, what number is it reaching?
3.
Okay, I'll take that. 3 it is. Maybe I should get credit for the review, right? All right. I think I'm going to change my pen color for one-sided limit. We are now reaching -3 on the right side. So here's my -3. And it says from the right side. The right side is right here. Where is it going? Yes, you could say infinity. What else could I say if I wanted? Does not exist because it's not a finite number. But I'll go with the infinity because the one-sided limits will go to infinity or negative infinity. Okay, now let's go to 8 from the left side. So let's find 8.
Wait, why was it infinity if there's a point?
There's not a point. On the left, there's a point. On the right, there isn't. Okay? So on my 8 from my left, so here's my left. And if y'all can kind of try to like match up, I see it pretty close to 4. Of course, it'll be very clear, except this one is not that clear, right? Are we ready for H? Let's reach 10. Go to 10 from the right side. 10 from the right side is getting closer and closer to some number. I see 7. If you can line it up. Oh, yeah. And then what about 10 from the left? 3. So here's 10. Yep, it's lower than 4. 3. I'll take that. Almost to the last one. We're now reaching -1 from the right. So -1 from the right. Yep, that's going to 3. And yes, I'll give you a graph like this. And then at the end, it's asking us something. It's asking us limit as x approaches to c of the function is going to exist everywhere in. Now be careful on this. How many of you guys see 1, 4 as a order pair? If it is within, that's going to be an inequality. What does it mean by inequality on that one? If we have parentheses, it means something. If it's a bracket, it means something. Okay, let's go to rewrite this. This right here means 1 less than x less than 4. Which is also translated as 1, 4 in our interval notation. Are we reminded of that? Yes, very good. I think that not having a bracket might have been confusing. So let's look at 1 to 4. So here's 1 to 4, and it's saying limit does exist everywhere on 1 to 4. So is that true? So let's go ahead and point at it. Y'all ready? Okay, so here's 1, here's 4, and I'm going to highlight the piece. So here's 1, and here's 4, and don't mind me on that. I kind of went over the open circle, and let me enunciate that. There you go. So if I point here, does a limit exist? Here? 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 Oh, it exists everywhere. True. Boom.
There's no limit.